So we've come up to the southern part of Thinia. We've come to a very high elevation, as you can see, and the reason we've come here is that there is a major fault that runs along the valley that's immediately beneath our feet, and what we're testing here is whether that hillside was once at the same level as to where we're standing and has moved both laterally and down the hill to be displaced along this fault, along this valley, and to try and work out if and when that happened. So these features and this particular fault runs for several kilometres along this valley, across the hill and down the other side. So the volume of rock is absolutely enormous that will have been translated at some time in the past out towards the west of this area, and this is effectively the head wall or the back scarp of the landslide itself, the rockfall and the rotation. And what we're trying to do along this surface is to try and work out when this took place. Was it millions of years ago, or was it just thousands of years ago?
This is a very tectonically active area, and it's that we're probably looking at to make movements on this scale. The time interval here is very, very short, right? But as I've talked to John this morning, we've had magnitude 7 earthquakes. The one rule is you can always have a bigger earthquake than the one you've had, and you may well have had a bigger earthquake. Now, these are big earthquakes, but we might have had a magnitude 8 here.
If you've got something that's like this and it moves, you expose that surface. So you try to get age dates on it. If that movement was slow, then obviously it's going to have different age dates along it. So we take a series of bricks through here to see if it was one slip with all the same ages, or in fact was it incremental, and so we get different ages for each earthquake that led to the exposure. The surface itself shows a change over time as a result of the rays that are coming in and hitting that particular surface. The longer it is exposed, the more that activity takes place. And so you're trying to record that, you measure that, go back to the lab with the samples, and you get an age date for how long that surface has been exposed to sunlight. These surfaces look as though there's single events on the scale that we've been looking at here. We need to do a transect of the whole hillside to determine whether that's true for the biggest surfaces that we see, where there are small individual slip planes, but actually we've got to do it for the whole hillside.
That's right. It gives us an estimate of the magnitude of the event. The more that slipped in one go, that determines the magnitude of the earthquake.
And if the same age is at the top of the surface and at the base, and in this case, this isn't a small fault, but the whole hillside, if that age is the same as that, that's one mega slide, one single event. And if we can date this and demonstrate that it has moved in the last 2,000 years, this explains the loss of the channel further to the west, because as this moved west, it also shoved things up into the air. So that there are a whole series of deformation features in the valley, which may, if there was a marine channel running through here, Strabo's channel, 2,000 years ago, then what's happened to it is it's been uplifted, shoved to the west and displaced.